Woo, I was having some trouble getting set up here. All right, so here we are. And let's just go from the current slide. All right, hang times, fouls, and flopping. All right, we're just going to get to hang times. I had created a whole three part unit to this, but we're just going to. Okay, so the question is, do athletes defy gravity? And what is hang time of a pro basketball player during a dunk? That's all we're going to look at, okay? That's all we're going to do with this. So you can see, yeah, this idea was pretty old, from 2010. The videos you watched earlier were from the 2017. Those guys are amazing. Just amazing. But anyway, hang time. Okay, do elite basketballs. Now this is that Martin Farquhar video. So you've already seen that, so we don't need to sit through that again. But go ahead at this point, if you haven't watched it, you can plug it in. You can type it in here, or you can just go to the video screen on the sheet. And we found out that it appears like in that last, it appears like they defy hang time by varying their center of mass, by the way they move their legs and arms, and it keeps their head on a straighter line. It doesn't follow an arc. Their head kind of stays nice and flat. They elongate their bodies because they're amazing athletes. And so it looks like they float longer than us humans, but they really don't. All right, hardcore physics, kinematics, description of motion. When we drop things, when things go up, they must come down, right? All right, so we need distance and speed, things we need to know. We need to know what's the acceleration, kinematic, constant acceleration, free fall. We need to know these kinds of things. You already know a lot of this stuff. You just didn't know that when you're doing velocity times time, you're doing a kinematic equation, okay? So here you go. Average velocity. This is very helpful. The average velocity is very helpful. Let me go to the ladybug here. Excuse me. And here's what we use the average velocity for. If we know that the acceleration is constant, if the acceleration is constant, okay, the acceleration is constant, and it's going to be when we're jumping. You know why? There's two accelerations. There's the massive acceleration when LeBron James or somebody like that pushes on the floor, and then the floor pushes him up. Okay, that's how you get airborne. The floor pushes you up. All right, and there's a massive amount of acceleration that lasts there for only like 0.05 of a second, if that long. All right, and then so this massive, in other words, our impulse, remember that from the NFL films that we were watching earlier in the semester, equals delta t equals our change in momentum. That's one way to look at it. All right, and here's that massive acceleration right here. All right, so we've got that. But if the acceleration is constant, but then there's the second acceleration that once those feet, those big old feet, leave the floor, once they leave the floor, then the only acceleration that's affecting them is gravity. Downward, 9.8 meters per second squared. All right? And then, because it's constant acceleration, we can use this. We can use the average velocity equals, the distance is equal to the average velocity times time. So if we know, except we actually use y, because we're in the y-axis when we're going up and down, we'll know the average velocity times the time, and then we can find out the hang time without much trouble. All right, so I've already scared you, but that's all right. We'll keep going.